Download this code from codegive.com, link in the description below. Beware of these 3 common wiring mistakes on outlets and switches, with code examples. Wiring outlets and switches might seem straightforward, but even seasoned DIers and some professionals can fall prey to common mistakes that can lead to dangerous situations, code violations, and malfunctioning electrical systems. This comprehensive guide details 3 of the most frequent errors encountered when wiring outlets and switches, explaining why they are hazardous, how to avoid them, and referencing relevant sections of the National Electrical Code, NEC. Disclaimer: This guide is for informational purposes only and should not be taken as a substitute for professional electrical advice. Working with electricity can be dangerous and potentially fatal. If you are not comfortable working with electricity, consult a licensed electrician. Always follow local electrical codes and regulations. Understanding basic wiring concepts. Before diving into the mistakes, let's review some fundamental concepts. Ground wire, green or bare, provides a path for fault current to return to the source, tripping the circuit breaker or fuse and preventing electrocution. It's crucial for safety. Neutral wire, white, carries current back to the power source, completing the circuit. Ideally, it should have 0 voltage potential relative to ground. Hot wire, black, red, or blue, carries the electrical current from the power source to the device, outlet or switch. It is always energized. Wiring methods. Refers to how wires are connected to devices. Common methods include terminal screws. Wires are wrapped around screws on the device. Push-in terminals. Back wiring wires are pushed into holes on the back of the device. These are generally less reliable than terminal screws. Wire connectors. Wire nuts. Wires are twisted together and capped with an insulated connector. The 3 common wiring mistakes. 1. Improper grounding, the silent killer. Description: This is arguably the most dangerous and frequently made mistake. It occurs when the ground wire is not properly connected to the outlet or switch, or when the grounding system itself is compromised. Why it's dangerous? Electrocution hazard. If a fault occurs, example, a hot wire comes into contact with the metal casing of an appliance, the fault current will not have a low resistance path back to the source. This could energize the appliance casing, making it a shock hazard to anyone who touches it while grounded. Fire hazard. If a large fault current is present without a proper ground, it can generate significant heat, potentially igniting surrounding materials and causing a fire. Damage to equipment. Sensitive electronic equipment can be damaged by surges or static electricity if not properly grounded. How to avoid it? Always connect the ground wire. Every outlet and switch should have a correctly connected ground wire. Connect to the grounding system. The ground wire must be connected back to the main electrical panel's grounding bus bar, which is connected to the earth through a grounding electrode, usually a ground rod or water pipe. Inspect existing grounding. Before working on any circuit, inspect the existing grounding system to ensure it is intact and properly connected. Use self-grounding outlets and switches, where appropriate. If the electrical box is metal and properly grounded, using self-grounding outlets and switches provides an additional layer of grounding protection. Never use the neutral as a ground, bootleg ground. This is a dangerous and illegal practice where the neutral wire is connected to the ground terminal. This creates a shock hazard because the neutral wire is intended to carry current and might not always be at ground potential. Code references, NEC examples. NEC 250.4, A, 5. Electrical equipment and wiring shall be installed in a manner that creates a low impedance ground fault current path to facilitate the operation of the overcurrent device. This emphasizes the importance of a low resistance grounding path. NEC 250.130, C. Equipment grounding conductors shall be sized in accordance with 250.122. This ensures the grounding wire is of adequate size to carry fault current. NEC 250.146 addresses equipment grounding requirements for receptacles installed in boxes. NEC 406.4, see this section outlines requirements for grounding type receptacles. NEC 250.32 discusses grounding separately derived systems. Wiring example, correct grounding. Wiring example, incorrect, bootleg ground. How to test for a good ground asterisk. A simple way to check for a proper ground is to use a circuit tester. Plug it into the outlet and check for the following. Hot neutral should read approximately 120 V, in North America. Hot ground should also read approximately 120 V. This indicates a good ground. Neutral ground should read close to 0 V. A significant voltage indicates a potential problem with the neutral or ground connections. Using a multimeter provides more accurate voltage readings. 2. Reversed hot and neutral wires, the sneaky hazard. Description *. This occurs when the hot and neutral wires are connected to the wrong terminals on the outlet or switch. The hot wire should always connect to the brass-colored screw terminal, and the neutral wire should connect to the silver-colored screw terminal. Why it's dangerous *. Shock hazard with switched devices *. Even when an appliance or lamp is switched off, the unswitched hot wire is still connected to the device. This means the internal components are still energized, presenting a shock hazard if someone touches them. Appliance malfunctions Some appliances are designed with the expectation that the hot wire is delivering power. Reversing the wires can lead to malfunctions or damage. Difficult troubleshooting Reversed polarity can make it difficult to diagnose other electrical problems. Phantom loads Some electronic devices can continue to draw a small amount of current even when off if the hot and neutral wires are reversed. This contributes to energy waste and can shorten the lifespan of the device. How to avoid it Follow wiring color conventions black, or red/blue, for hot, white for neutral. Double check connections before energizing a circuit, carefully double check that the wires are connected to the correct terminals. Use a circuit tester after wiring an outlet or switch, use a circuit tester to verify that the polarity is correct. Most testers will indicate a reversed polarity fault. Work with adequate lighting ensure you have sufficient lighting to clearly see the terminals and wire colors. Code references, NEC examples. NEC 200.11 requires the neutral conductor, identified by white or gray, to be connected only to the terminal or conductor intended for it. NEC 406.3, A requires receptacle terminals to be identified for proper polarity. Brass/bronze colored terminal screws are designated for the ungrounded, hot, conductor, and the silver colored terminal screw is for the grounded, neutral, conductor. Wiring example, correct polarity. Wiring example, incorrect, reversed polarity. How to check for reversed polarity Use a circuit tester. It will typically light up indicating a reversed polarity issue. You can also use a multimeter to measure the voltage between the hot and neutral terminals and between the hot and ground terminals. If the hot neutral reading is significantly lower than the hot ground reading, or if the hot ground reading is significantly higher than expected, example closer to 240 V instead of 120 V, it's a strong indication of reversed polarity. 3. Over-tightening or under-tightening terminal screws, the connection killer. Description: the screws on outlets and switches need to be properly tightened to ensure a secure and reliable connection. Too tight, and you risk stripping the screw or damaging the wire. Too loose, and the connection can become unstable. Push-in terminals are especially prone to failure if the wire isn't fully inserted. Why it's dangerous. Loose connections. A loose connection creates resistance, which generates heat. This heat can melt insulation, damage the outlet or switch, and even ignite a fire. Intermittent power outages. A loose connection can cause intermittent power outages or flickering lights as the wire loses and regains contact. Arcing. A loose connection can create an arc, which is a spark of electricity jumping across the gap. Arcing generates intense heat and is a major cause of electrical fires. Wire degradation. Over-tightening screws can damage the wire, weakening it and making it more likely to break. How to avoid it. Use a torque screwdriver. Recommended: a torque screwdriver allows you to set the appropriate tightening torque for the screws on the device. This ensures a consistent and secure connection without over-tightening. The device manufacturer will often specify the torque. Tighten firmly, but don't overdo it. If you don't have a torque screwdriver, tighten the screws firmly until they feel snug, but avoid applying excessive force. A slight turn past snug is often sufficient. Check for loose wires. After tightening the screws, gently tug on the wires to ensure they are securely connected. Proper wire preparation. When using terminal screws, create a hook in the wire with pliers and wrap it around the screw in a clockwise direction, so tightening the screw pulls the wire in. Strip the wire to the correct length to avoid exposing too much bare wire or leaving too much insulation under the screw. Avoid back wiring where possible. While push-in terminals, back wiring, can be quicker, they are generally less reliable than terminal screws. If possible, use the terminal screws instead. If you must use back wiring, ensure the wire is fully inserted and locked into place. Periodic inspection. Check outlets and switches periodically for signs of looseness, such as flickering lights or warm outlets. Code references, NEC examples. NEC 110.3, B requires electrical equipment to be installed and used in accordance with the manufacturer's instructions and markings. This includes tightening torque requirements for screws. NEC 110.14, B addresses the tightness of connections and states that connections shall be torqued as specified in the manufacturer's instructions. NEC 314.4 addresses securing conductors and cable assemblies to boxes. Wiring example, correct screw tightening. Wiring example, incorrect, over-tightened screw. Wiring example, incorrect, under-tightened screw. Tools and materials to help avoid mistakes. Circuit tester. To verify polarity, ground, and identify open circuits. Multimeter. For measuring voltage, current, and resistance. Wire strippers. To strip insulation cleanly and accurately. Pliers, needle nose and linesman for bending and twisting wires. Screwdrivers, flathead and Phillips. Consider a torque screwdriver for precise tightening. Wire connectors, wire nuts. Use all listed wire connectors for making secure splices. Electrical tape. For insulating wire connections, use sparingly, wire connectors are preferred. Voltage tester, Non-contact to verify that a circuit is de-energized before working on it. Asterisk flashlight or headlamp. Asterisk adequate lighting is essential for safe and accurate wiring. Asterisk safety glasses. Asterisk protect your eyes from flying debris. Asterisk work gloves. Asterisk protect your hands from cuts and abrasions. General safety precautions. Asterisk always turn off the power. Asterisk before working on any electrical circuit, turn off the corresponding circuit breaker or remove the fuse at the main electrical panel. Use a voltage tester to verify that the circuit is de-energized. Asterisk work in a well-lit area. Asterisk ensure you have adequate lighting to see clearly. Asterisk wear appropriate safety gear. Asterisk wear safety glasses and work gloves. Asterisk follow the NEC and local codes. Asterisk adhere to all applicable electrical codes and regulations. Asterisk if in doubt, call an electrician. Asterisk if you are unsure about any aspect of the wiring process, consult a qualified electrician. It is always better to be safe than sorry. Conclusion. Asterisk avoiding these three common wiring mistakes: improper grounding, reversed hot and neutral wires, and improperly tightened connections, is critical for ensuring the safety and reliability of your electrical system. By understanding the potential hazards, following proper wiring techniques, and adhering to electrical codes, you can minimize the risk of electrical shock, fire, and equipment damage. Remember, when in doubt, consult a licensed electrician. Electrical work is not something to guess at.